Good morning. Thank you all very much for coming to our keynote. And once again, thank you KubeCon for having us. My name is Ana Margarita Medina. I work at Gremlin. And here with us, we also have Lenny Sharpe. Today, we'll be talking about finding the joy in chaos engineering.
So as you've heard, my name is Lenny Sharpe. I'm the Director of Engineering and Infrastructure Operations at Target, and I lead the Resiliency Engineering Enablement team. We're responsible for driving our disaster recovery and chaos engineering capabilities.
As I mentioned, I'm a chaos engineer. I work at Gremlin. I break software. I wonder how things are resilient, how things are reliable. I got to do this prior to joining Gremlin at Uber, where I did chaos engineering and I was helping Uber move to the cloud. Other things that I love doing apart from working in tech is trying to bring more diversity into the tech space, especially people of color. And other things that I love doing is also helping break the stigma around mental health. Mental health is real, yo. But to set the stage today, I first want to go over some definitions of the topics that we'll be talking about today. So, first of all, what is chaos engineering? Chaos engineering is thoughtful, planned experiments designed to reveal the weakness in our systems. If you're wondering how you do experiments, well, if anyone remembers a scientific method that they learned when they were growing up in science class, we use exactly just that. We examine our systems and we start by forming a hypothesis. You don't need to know exactly how everything works. You do this in a team setting. After coming up with this hypothesis, you want to go and actually implement this as an experiment and test it. After you see this experiment happen, you want to analyze those results. This is also the part where hopefully you would have come up with an abort condition. If that abort condition would have happened as you were going through your experiment, you would have safely halted that experiment. If that experiment was successful, well, you want to go ahead and expand that scope. Is what we like talking about as blast radius. That could be the amount of hosts or containers that you're running an experiment on. And then you also want to expand the magnitude of your experiments. That means how the strength of your chaos engineering experiments. And we'll see that later on as we go through our demo. But after you do the experiments, the other thing you need to be doing is actually sharing your results. This is about building a culture around resiliency and letting folks know how your applications were breaking and also giving back to the community. The other term that we'll be discussing today is game days. Game days are a dedicated time to come together to gain insights. It's an opportunity to execute one or more experiments. So if you were wondering why you should be doing something like chaos engineering, well, that is because the cost of downtime is extremely expensive. Can I go back to the last slide? Yeah. And that video should play too. Thanks. Well, as you can see on the video behind me, we see the cost of downtime that is happening if any of these e-commerce websites were having an outage right now on a non-high peak traffic day. As you can tell, it's extremely expensive. That complexity of retail tech only continues to grow, and with that increases the chances that system disruptions or even downtime can occur. This is why we are here today. We know it is not a matter of it is not a matter of it's actually going to happen. It's a matter of when it's going to happen. But chaos engineering isn't the fix to this, but it is a capability worth investing in. And if you're looking to improve your reliability and resiliency, you want to make sure to do this.
So as Anna alluded to, downtime for any organization isn't good, especially retailer and heading into one of our busiest seasons in the next couple of weeks. So this is why we started our journey into chaos engineering at Target. We wanted to get ahead of issues before they became outages. But as we were growing, we were also up against a major transformation at the time a few years ago when we started this journey. Terms like chaos or IT resiliency were more buzzwords. They weren't concepts anyone wanted to get behind at the time. So we needed to move forward. No one was asking us to do this. And when I was thinking back to when this journey began, I thought about a quote that one of my mentors used to use. And it was, "Don't wait for your ticket to the dance, just show up." And we needed to do that. Having the confidence to do something in a large organization that hadn't been done wasn't going to be easy, but we had to embrace the challenge. I had a team of engineers that were very passionate and highly skilled that wanted to make this happen, and we did just that. So Target is big. The sheer size and scope of the organization and the tech that we use gives us some unique challenges. With over 1,800 stores and 40 distribution centers, with Kubernetes clusters running in both stores and DCs, it's very challenging for us to have a one-size-fits-all approach. So as we started thinking about chaos engineering, we had to take a very thoughtful approach. How many of you have been told something's not going to work when you've had a great idea? I think everyone can relate to that. Well, we had an uphill battle ahead of us. Chaos engineering was still a new term, and if people heard of it, they considered it more of a load testing or performance testing type capability. Across Target, we didn't have good steady state. As I mentioned, we were going through a major technology transformation where we're implementing more state-of-the-art technologies. Leaders were skeptical, and if they had every right to be, because we were competing for resources when we were trying to break things and they were trying to rolling out new features. But we had this opportunity to help them with everything. We knew chaos engineering would give us the ability to help better understand dependencies, improve our observability, and overall better understand how our systems would operate.
So I mentioned I worked at Gremlin. Gremlin is the resiliency company that offers a chaos engineering platform, and Target turned to us to figure out how they can do chaos engineering experiments in a precise, easy, and safe way. So we built a journey and a roadmap to make this come to life. At first, it was about just developing the strategy and introducing it to leaders across the organization. From there, we started to learn and iterate. We wanted to do one game day a quarter, and then we wanted to move into one game day a month, now doing them generally more than a couple a month, and even doing self-service. Our goal as we continue to move forward is to improve the overall culture and adoption of chaos engineering in the organization. And my team is laser focused and increasing the amount of automation and scale and scope as we head into 2020 for our chaos experiments. So in the beginning, it wasn't easy. We had to look across the organization and find teams that might have already been doing chaos experimentation. In this case, we reached out to our release and runtime engineering team that was doing fire drills. They would have engineers manually break services and let more junior engineers have to diagnose and detect what was going on. This was great. Our team got to basically see a game day happening that wasn't formally a game day. It was just teams coming together to better understand their systems. But the team had one problem. They were manually doing this. Having a tool or more tools to use to increase the automation around this would improve the amount of time they were spending on these exercises. And that's where we came in. So we started to run formal game days using tools. In this case, it was a team that was focused on our supply chain organization. They were using Kubernetes, and it was a great opportunity because the senior leader would kill pods randomly and watch his team respond. Not something those engineers enjoyed. So in this controlled environment, we're able to find and outline hypothesis and attacks so they knew what they were getting into. We decided that running this game day with them was going to be impactful. And so we found a couple great findings. The first being with auto-scaling. The team thought everything with their Kubernetes clusters was bulletproof and super resilient, but they're able to make minor tweaks moving forward and apply those to other applications that weren't tested during this that were in production. After this, we're able to take this success and continue to grow the program. So we've done our first official game day leveraging a tool, and it worked. We're experts, right? Well, that's what we thought, and we needed to act that way. But we still had a long road to go. We didn't need to go backwards, we needed to look forwards. And in this case, we wanted to continue to market and share our results both internally and externally at Target. And we wanted to develop our own platform to continue to grow and conduct more attacks.
So my team developed TRAP, Target Resiliency Automation Platform. TRAP is a platform used to conduct chaos experiments, leveraging software as a service and open source tools. And in the future, it's going to enable us to automate our disaster recovery exercises. We've integrated with other Target services to provide notifications when experiments are happening so that teams that are running other applications can understand what's going on. Soon, we're going to automate gathering other metrics from other dashboards into our platform, which will allow for quick sharing of the results of these experiments. We built TRAP with one focus in mind: to find faults before they become outages and to create an experience for our engineers that make them want to use this tool. So we want to have some fun with it. We used to go to different demo days and market TRAP and what we could do with it. So the team came up with this menu concept. As you can see, the various specials are the kinds of attacks you can run. We were able to give this out to a lot of different engineers, and they could even Slack us what types of attacks they wanted us to run with them. Apparently, latency is the most important attack to run, and it's the spiciest, as you can see as well. Then, just recently at a demo day, the team got very creative and started looking at trick or trap. We took the menu concept and created a spell book. Really, really happy with how this turned out, and we could have curses or hex acting as attacks on systems. Just another way to be creative and to market chaos engineering in our organization. As I mentioned, we have demo days where thousands of engineers at Target get together, so we continue to market that. We leverage hackathons as a way to break systems as well as look at integrating other systems at Target with TRAP. We bring in industry leaders to come speak at our internal events so we can validate the path that we're on. And finally, we co-host the Twin Cities Chaos Meetup Group, where we bring in experts across the US to speak about chaos engineering to get other organizations in the Twin Cities more information about how they can grow and develop chaos engineering capabilities at their organizations.
So Lenny just mentioned the Twin Cities Chaos Engineering Meetup, but it doesn't just stop in Minneapolis. There is chaos engineering meetups happening all over the United States and across the world, all the way from Colombia, all the way to London, all the way to Australia. We foster these online communities too, but we also want these folks that are living all over the world to come in IRL, AKA in real life, and get together to share their learnings with chaos engineering. So just 2 months ago in San Francisco, we held the 2nd annual Chaos Engineering Conference. We brought together 600 minds to get some hands-on learning experience running chaos engineering on Kubernetes, and then they also got to learn with various folks in the industry that are practicing chaos engineering at their companies. Some of those minds included folks that worked at MailChimp to Expedia, and they got to talk about breaking through in their chaos engineering practice. With this community, we also like talking about open source and how we're taking our learnings to make other software more resilient. So today, I'll be doing a little bit demo of using chaos engineering. I'll be using the Google Cloud's platform microservice demo. It's a very typical 10-tier microservice. As you can see here, we have an architecture diagram. We have various applications that are running. But first, I want to show you what the steady state of this application looks like. We're able to go on to the site, very typical like in e-commerce. We can browse it. We can go look for an item that we're interested in shopping. I'm going camping next week. I want to buy 3 mugs. I can go ahead, add that to my cart. Then I want to go browse more products. And I want an expensive camera, because why not? I've added that to my cart. I see all the payment information is right. I place my order. Boom, my order is complete. That was easy. But now I actually want to do chaos among this. So I'll go over to Gremlin, select attacks, create a new attack. Then I'm going to go over to the Kubernetes tab. I want to choose the cluster that I'm using today, which is running on Amazon EKS. Then I want to find the namespace that this has been deployed on, which is the default namespace. Here, now I see all the deployments under this microservice. And I want to start with targeting the product catalog. I would now like to add some latency to that experiment. So I'll go over to the network side, then I'll select latency. And I'll start by saying that I want to run this experiment for 120 seconds. I want the magnitude for that experiment to be injecting 1,000 milliseconds of latency. So I'm now starting my experiment, but I want to talk about the abort condition. I'm now injecting 1 second of latency. I expect my application will be usable by users, but if I see that latency be more than 1 second, I want to go press what we call the big red button in chaos engineering and stop that experiment. So we'll go and actually select the details of this attack. We see that it's starting to get ready for running. We'll go back to our demo application, and we'll try opening the vintage typewriter. And this is starting to look that it's actually taking a little bit longer than just 1 second to run this experiment. Let me do one more try. Let me add this to my cart. That's definitely more than 1 second of latency. This is actually affecting our customers if we were doing this in production. So, you know what? I'm going to actually go ahead and say that I hit my abort condition. I want to go press that big red button and stop this experiment. I think that this application is not handling 1,000 milliseconds of latency quite well at all. I've halted it, and this experiment is now rolling back. So with this, I have found that if some latency was to happen in my cluster, in my application, maybe I'm realizing that things are not as decoupled as I thought. I was expecting 1 second of latency across those calls. There was a lot more than that. So with that, I want to say that we have been researching a lot of failures and outages that have been caused as folks are running Kubernetes at a large scale. And with that, we've seen that about 25% of these outages are happening just because folks are not auto-scaling things at all. They're not doing any horizontal pod auto-scaling, and they're not actually even auto-scaling on the resource layer on the nodes. So we strongly recommend for folks to be doing CPU attacks to actually test how the resources on Kubernetes are getting affected. And if you're setting resources limits, are you actually going on your containers and actually testing them? The other thing that we've also seen is that a lot of failures on Kubernetes actually happen due just to the network. And those are things that include attacks such as latency, packet loss, black hole. And this is also a great way to actually see how you fail when your dependencies are going wrong. How is your application handling failures when your dependencies go down? And is your application actually handling errors due to latency? The other fun one that we actually see is that a lot of us are just using Kubernetes because it's super resilient. But we actually don't think about what happens. Let's say our container was to actually shut off or die, and we just assume that another container is actually going to come back up. Well, when that container is getting respawned, how is your application actually loading during those few seconds that it takes?
So for us, the road ahead means more testing. We need to continue to test to look for vulnerabilities before they become outages. I challenge my team to think about what are the big pigs flying, and then how do we build a roadmap to get there? So for us, we want to see more increased OKRs around experimentation. We want to have more accountability to ensure teams are testing on a regular basis, as well as moving into production with continuous testing occurring all the time. We want to increase that overall scope and scale, ensuring that our most critical guest-facing applications are having chaos experiments run to identify weaknesses. And ultimately, we want to see incident data blended with this experimental data so that we can proactively identify what types of attacks should we be running in production on a continuous basis. So as a kid from Buffalo, I had to throw in a Buffalo Bills reference and a famous coach from Buffalo. So whether you're rolling out a new chaos engineering capability in your organization, or you have a super resilient Kubernetes technology, or you're trying to implement something that hasn't been done, there's going to be failures, and that's okay. We need to embrace those failures and recognize that they're going to happen, and that's fine. But enjoy the successes along the way as well.
And with that, we want to share that failure is part of the success. We are all learning from our failures. So we would like to invite you to come and join the chaos engineering community that has over 3,500 folks that are just getting started in their practice to some folks that have been doing this for 10 years. We would like to continue sharing our failures on our successes that we've had with Kubernetes, just to continue making Kubernetes more resilient and continue helping build a resilient internet.
So thank you for listening to our presentation today. Hopefully there's something you've gained that can help make your systems more resilient. If you have any questions, feel free to reach out to Anna or I, and we can help you with more. Thank you.
Thanks.